Alright, so section 510, we're going to be taking a look at the inverse trig functions, which you guys have been doing this. When we were finding missing angles of a triangle, you did the inverse sine, inverse cosine, or inverse tangent to help you find the inverse. We're going to continue with that, but then I also want to show you another notation that might be used, as well as why is it that your calculator only gives you one solution. Okay, so with that being said, like I said, you guys have been evaluating inverse functions all along, trying to solve for theta. So here I have the unit circle. We're talking about thetas between 0 and 2 pi. And so if you're trying to solve for theta between 0 and 2 pi, and we're asking for, okay, sine of theta equals 1/2. So I'm going to look for where on my circle is the sine of theta equal to 1/2. So I see, well, here sine is 1/2, and here sine is 1/2. So that would be saying that between 0 and 2 pi, theta would be at pi over 6 as well as 5 pi over 6. So there are two solutions. Okay. At cosine, and I look at here, so the inverse cosine of negative square roots of 2 over 2, I see cosine here is negative square roots of 2 over 2, here is negative 2 square roots of 2, so that would be that theta is equal to 3 pi over 4, as well as 5 pi over 4. Alright, and then what about tangent? So when is tangent equal to the square root of 3? Well, tangent, for it to be positive, would have to be in quadrants 1 and 3. And where we are going to have the square root of 3 is going to be at pi over 3 and at 4 pi over 3. Remember, I'm just taking the square root of 3 over 2 divided by 1/2 to find out what that tangent value is. So here's our problem, is if I go to my calculator, it's not my calculator, here's my calculator, and I get rid of this, and I'm going to go into degree mode real quick, just because that's going to be a little bit easier for us to see. If we take a look at when theta is at pi over 6, well, that's 30 degrees. Okay, so we got 30 degrees right here, and then 5 pi over 6 is 150 degrees. When you solve this in a calculator, we take the inverse sine of 1/2, and that's going to give us theta. So I go to my calculator, and I do the inverse sine of 0.5, and I hit enter, and I get 30. Again, I'm in degree mode, that's 30 degrees. But notice that I'm not getting also 150 degrees, and I'm looking between 0 and 2 pi. That is because when you start to look at inverses right here, your inverse technically is not a function, okay? And what we end up having to do here is we have to restrict our domain to get to that point. So I am going to jump down to here for a moment and to show you this graph. Now I took our sine curve and our cosine curve and I put them along our x and y axis here, and looking for 0 to 2 pi. Now I'm using sine of theta equal to 0.4. You guys would have to find this, take the inverse sine of 0.4 to get your answer. And what you're doing here is you're really looking for, when does our sine curve here equal 0.4? And that shows us on a period of 0 to 2 pi that it's at 2 solutions. Now, once again, if I go to my calculator, and I'm going to change my mode to radian mode now, and I take the inverse sine of 0.4, I get 0.41 radians. And that is where we are crossing over that red line. Okay, but now there's two solutions between 0 and 2 pi. We are going to be getting into finding those solutions in the next chapter here, but what I want you to realize is that your calculator is not giving you two answers, and to be quite honest with you, you have infinitely many of solutions here if you're looking at a domain of all real numbers. We're just looking at a domain of 0 to 2 pi right now. And so what is it about your calculator that does this? So let me take you back to when we talked about the quadratic function and the square root function. Now, when you take the inverse of the square root function, you get y equals the square root of x. But what does not happen is notice that it's not that full parabola that's on its side. The reason for that is because now it doesn't pass the vertical line test. That would mean that your square root graph here would not be a function. Well, we needed it to be a function to be able to use the different function properties and things like that. So what do is you'll remember that we talked about restricting the domain of your quadratic. So we said, well, okay, so if it's not going to work having both those, well, let's just forget about the negative part here and only work with the positive values. And when we take the inverse of that, then you're just working with the positive square root of x. You're not working with the plus or minus the square root of x. And now, when I do my tests here, now we know the quadratic is a function. Now when I do the horizontal line test without that left-hand side here, now it passes the horizontal line test. Now it's a function. Now right here, this is a function as well. Well, we have to do the same thing when it comes to our sine, cosine, and tangent. We have to restrict the domains so that it ends up being a function. So let me start out with the sine function here. Okay, now, if I were to take this yellow box right there and extend it from 0 to 2 pi, you'll notice that it passes the vertical line test. It does not pass the horizontal line test. So that means the inverse is not a function. So we try and restrict it a little bit. I'm going to pull this in. Let's say I go from 0 to pi. Well, that still does not pass the horizontal line test, okay? So I bring it in further here, and I go from 0 to pi over 2. Well, we're getting closer. Now that does pass the horizontal line test, but it doesn't create all necessary solutions. And so now what we're going to do is we are going to extend this to an interval of negative pi over 2 to positive pi over 2. Because this interval right here, okay, first of all, it extends the entire range of our parent function, okay? So the entire range is within this interval, within that specific domain. So we're going to use the domain of negative pi over 2 to positive pi over 2 for our date. Now if I just take that snapshot right there and I do a horizontal line there, it's going to pass through, and so therefore the inverse is a function. Passes the vertical line test too. Notice how goofy the graph kind of looks over here to the left. Now there is a beginning and there's an end to it. It does not go have an end behavior, okay? When we do inverses, remember everything gets flipped. So now my domain goes from negative 1 to positive 1. My range goes from negative pi over 2 to positive pi over 2. Now, I'm not going to have us necessarily graphing these all out. You can graph them on your calculator if you wanted to. We're just going to take a peek at them right now. Now, it changes when you get into cosine, because cosine, if I go on that same interval from negative pi over 2 to positive pi over 2, you'll notice that we don't hit the whole range. And so I'm going to slide my domain here, and now my restricted domain, in order to cover the entire range, is going to go from 0 pi to 1 pi. And that will accept the entire range from going from negative 1 to positive 1. And so its graph, when you look at it here, domain goes from negative 1 to positive 1, and its range goes from 0 to pi. And you see that curve to it. And then tangent, if I go on that 0 to pi, like we are talking about here, now it does have the entire range. Our only issue is that it's a discontinuous function now because it's got that vertical asymptote in there. So in order to ignore that, we go back to like when we were working with sine, and we work with a restricted domain going from negative pi over 2 to positive pi over 2, because then you don't have to worry about any undefined values within there. Now, this function here does have an end behavior to it, okay? So, unlike sine and cosine, so with tangent, your domain is all real numbers. However, your range goes from negative pi over 2 to positive pi over 2. So you do have end behaviors of positive pi over 2 and negative pi over 2. Alright, so where does that lead us to? First of all, I want to show you that there are some different ways that you might see inverses being written out, and it just totally depends on what subject matter you're working with. If you get into like the physics world, instead of seeing that superscript of a -1, you're going to possibly see the word arc sine. And that is the exact same thing as an inverse sine. So here you have arc cosine. It's the same thing as the inverse. Arc, tangent, a lot of times they'll just use that in like a physics context a little bit more. But otherwise it means the exact same thing. So let's go ahead and do some evaluating of some values. And we're going to start out with just looking at cosine, okay? Now, cosine, its restricted domain is from 0 to pi, okay? So you have to ignore all these other quadrants here. So when I answer the question here of the inverse cosine of 1/2, when I look at my x values here, there's only one positive 1/2. I'm not going to use the one that's down there in quadrant 4. And so my solution here would be pi over 3. And pi over 3 is between 0 and pi over 2. Inverse cosine of negative square roots of 2 over 2. See that one right here? And so my solution here would be 3 pi over 4. When is the inverse cosine 0? Inverse cosine of 0 takes place at pi over 2. And so you have to look on that domain of 0 to pi. Okay, what about if you look at sine values? Okay, now you have to be careful here because you are going from negative pi over 2 to positive pi over 2. That means that this is no longer 11 pi over 6. This is negative pi over 6. And a bit more over here. So negative pi over 6. And 7 pi over 4, that's now negative pi over 4. 5 pi over 3, now that's negative pi over 3. 3 pi over 2 is negative pi over 2. Those are the values that we are now using. So the inverse sine of the square root of 3 over 2. So I look for it here, where's sine positive square roots of 3 over 2? That puts me up here. And so I see that pi over 3 is my answer. Alright, let's take a look at when is the inverse sine negative 1/2. So negative 1/2 is right here. People all the time want to put 11 pi over 6. The answer is negative pi over 6. Okay, if I go to my calculator once again, I'm going to go into the mode right here. I want to go degrees just because you guys will recognize that. And if I do, which one did I just do? Inverse sine of negative 1/2. Okay, inverse sine of negative 1/2. Notice it gives me negative 30 degrees. It is not telling me 330 degrees, it's telling me negative 30 degrees. Because my domain is going from negative 90 degrees to positive 90 degrees. Or negative pi over 2 to a positive pi over 2. Alright, lastly, here's inverse sine of negative 1. So I find negative 1 down here. the inverse sine of negative 1 is going to be negative pi over 2. Not 3 pi over 2, negative pi over 2. Right? Now, tangent is just like working with sine. So you are looking at your domain. Oops. You're going from negative pi over 2 to a positive pi over 2. So once again, think of your 11 pi over 6. Now that's going to be a negative pi over 6. 7 pi over 4 is negative pi over 4. 5 pi over 3 is negative pi over 3. And then you got negative pi over 2. So I'm looking for inverse tangent of negative 1. So I find my tangent of negative 1 right here. It's not 7 pi over 4. It's going to be negative pi over 4. Okay. When is the inverse of tangent 0? So see it right here. Be careful, it's not 2 pi. It's going to have to be 0, or 0 pi is when that's going to take place. Oops, try and keep things color-coded here, so let me just put this one. And then inverse tangent of square root of 3. Here's the square root of 3. Now that's on the positive part here, and that would be pi over 3. So definitely getting a look at those, trying to work those out. We'll be taking a look at some compositions of those then tomorrow. But I also just want to briefly talk about real quick a application, working out problems like this, and you might not realize that you are, using the inverse functions, but you are, okay? So it just says an angle of elevation from a football on a football field to the crossbar on the goalpost depends on D, the distance from, distance from the ball to the base of the goalpost. Okay, so here's theta. So what we're going to try and do here is we're going to try and come up with a formula or an equation for theta. And it says the angle of elevation from the football on a football field to the crossbar on the goal depends on D, distance from the ball to the base of the goalpost. So here, right here is D. So what many times people would do is they would set this up as, okay, well, the tangent of theta is equal to 10 over D, right? Now, another way that you could write this out is, let's say you wanted to solve for that angle theta. We can do I can say that theta is then equal to the inverse tangent of 10 divided by D. Or if you wanted to, you could say arctangent of 10 over D. And so it's just a different way for you to write out a formula solved for the actual angle itself. Alright, here's an example here. You've got two cables that are secured from the top of a 50-foot tall utility pole to the ground. The lengths of the cables are given as C1 and C2. We're going to try and see if we can find the formula for theta. Now, first of all, you've got to recognize that theta is between C1 and C2, and this is not a right triangle. Now, next chapter, we'll take a look at law of sines and law of cosines, working with non-right triangles, but we're going to want to use a right triangle in this situation. So, to find this angle, what we could do here is we could work with this larger angle and then subtract an angle inside here to get that angle, okay? So, so let's go ahead and treat this. I'm going to put, I'm going to do two different, because we would take one angle and subtract, take the bigger angle, subtract the smaller one. So let's start with the larger triangle right here. If I wanted to find the angle of that, of the top here, we would be using, let's see, we've got the adjacent and the hypotenuse, so that would be cosine. So cosine of theta would be equal to the adjacent 50 of the hypotenuse, which would be C1. And so now, once again, if I wanted to rewrite this, I could say that theta is equal to the arc cosine of 50 over C1. Now, so that's working for the large green triangle. Now, if I look at the smaller triangle, smaller right triangle, if I can work with that angle and subtract it from that green triangle, that will give me my leftover part of theta. I would also use cosine here. So cosine of theta would actually be 50 divided by C2 in this situation. So we would take the arc cosine of 50 divided by C2. And this is giving us what the angle would be for yellow triangle. So now to find actually what theta is going to be, I would take the green angle, subtract the yellow angle. So theta would be arc cosine of 50 divided by C1 minus arc cosine of 50 over C2. So just showing you how you can work the inverse functions into our everyday problems.